For years, NASA has been working on an amazing telescope. It's called the James Webb Space Telescope, or JWST, and at one point, it was intended to launch in 2007. We've been talking about this project since SciShow started, because James Webb could transform our understanding of the universe. But honestly, being a fan of this telescope is sometimes hard work. After years of seeing it fail tests and get postponed, things can feel discouraging. Today, though, I have some good news. Last week, after more than a decade of delays, the two halves of the telescope have finally been joined together. Although it won't do identical work, James Webb is the successor to the Hubble Space Telescope, which will likely stop working in the mid-2020s. And once Webb launches, it'll be charged with a full complement of missions. Using infrared light, it'll study the composition of exoplanets, probe the oldest galaxies we can see, and maybe even answer our questions about what the universe is made of. But before it can do any of that, it needs to launch. And before it can launch, it needs to be fully tested. Until recently, Webb's two main halves were tested separately, but now we can test them together. One half consists of the telescope itself. That's the part with gold-coated mirrors and a suite of instruments. The other half has the spacecraft, which will steer the telescope, along with the giant 5-layer sun shield that will block light from the sun, Earth, and moon. Blocking this light will help keep the telescope cold, which is a must since heat is a major source of infrared radiation. So if it's not cold enough, an infrared telescope's own heat can overwhelm its instruments while it's trying to monitor distant, dim objects. The sun shield will solve a lot of that problem, but the telescope will also have a bit of cold helium to keep some of its instruments extra chilly. Of course, just because the telescope is mostly assembled doesn't mean it's ready for launch. Engineers still have to connect the electronics between the two halves, and after that, they have to test them all together. They'll have to make sure they wired everything correctly and that the equipment will survive deployment and the vacuum of space. That means there's still room for error, but hopefully things will go well and the telescope will finally launch in March of 2021. Thankfully, even if Webb doesn't launch for a while, there's plenty of other work to do in astronomy. For example, researchers are still hunting for the first solid evidence of an exomoon, a moon orbiting a planet outside the solar system. Moons are usually much smaller than their planets, so even when we find an exomoon candidate, it's tricky to isolate the signal and confirm that it's actually there. One team of astronomers thinks there's a way around this, though. Their paper has been accepted for publication in the Astrophysical Journal, and in it, they propose you can find certain exomoons by studying their planet's chemistry. And using this method, they've even found an especially exciting candidate. This paper focuses on a type of planet called hot Jupiters. These are gas giants that orbit so close to their stars that their year could be as little as a few days on Earth. Until recently, there wasn't much evidence that a moon could exist in a stable orbit around a planet like this. So the first thing these scientists did was use math to confirm moons could live there. And next, they proposed a way we could identify them. Drawing on earlier research, they suggested you could find some exomoons by looking for certain gases in their planet's atmospheres. This idea is actually based on what researchers see with Jupiter and its third largest moon, Io. Io has hundreds of active volcanoes that spew out lava, sulfur-based gases, and other elements, like sodium and potassium. And some of those compounds get incorporated into Jupiter's upper atmosphere. That's important because at least in our solar system, elements like sodium and potassium aren't normally found in the upper atmospheres of gas giants. They only seem to get there through external sources like volcanic moons. So these astronomers hypothesized that if you detect either sodium or potassium around a hot Jupiter, it could have a moon like Io. The basic idea isn't new, but these researchers were among the first to see if it applied to hot Jupiters. And as it turns out, it might. In their study, they looked at data from 14 of these planets, all of which had sodium or potassium signatures in their upper atmosphere. Then they ran analyses and identified one that seems most likely to have a moon. It's called WASP-49b and is located 550 light years away. If this finding is validated, it would be the first confirmed exomoon. But even if it's not, this method is still a really creative way of studying objects that are super far from Earth. It combines the familiar things that are close to us with alien worlds hundreds of light years from here. At this point, it's unclear if this technique could be used to find moons like ours around planets like Earth, but hey, maybe we'll need even more creative methods to do that. There's a lot to explore in space, which is part of the reason science fiction is so fun. You get to think about what would happen if, say, a bunch of alien robots called Carl suddenly appeared on Earth. Okay, let me explain. About a year ago, Hank, who co-hosts this channel with me and started SciShow and does lots of cool things, released a book that he worked on forever called An Absolutely Remarkable Thing. And that book is now available in paperback, which is just so much more cozy to hold. So if space, robots, social media, or just the general state of humanity are things you're interested in, you can pick up the paperback of An Absolutely Remarkable Thing wherever you like to get your books.